Alright, welcome back guys. Let's get some more partial fractions going here. If you still are kind of unsure about how these work, make sure you go back and watch that first video. This is very similar, it's just there's other situations that can come up, so we're going to see a couple more possible things you can have when you're trying to break a fraction into smaller pieces. Okay, so for example, if we had something like this, we do notice how I factored the bottom for you, and the weird part about this one is that if you look right here, this factor is not a simple linear factor, it's still a quadratic, but it won't break down any further. You can factor that over the imaginary numbers, we will talk about that later in the year, but for now this is all we can really leave it as, and so when you go ahead and split this up into your possibilities, you are going to have two possible fractions here. X minus 1 will be over here, and x squared plus 4 will be over here. The main difference is, because the bottom here is more complicated, we have to allow for other things on the top of it. Okay, so essentially we would just normally put a number up here. We put like an A here and a B over there. The weird part is we're actually going to put something like this. We might have an X on the top of this, and we also might have a constant. And again, that's just because this is a higher degree factor there, so we really need to account for the possibilities that on top of it was higher as well. This A might be a 0, we might not need it, and we'll see that in some examples where we're just kind of allowing for all the possibilities. You could put an X on top of these at all times, but usually that's not going to be needed, so we're just going to put a C up there. Okay. After that, the process is the same. We're going to try to get a common denominator, put these together. We're going to make sure we can get this at the end, but the weird part is that if you have a quadratic factor that doesn't break down, we need to put a linear factor on top of it. Notice how basically this is degree 2, this is degree 1, this is degree 1, this is degree 0. So your top should always be 1 degree less than whatever you had on the bottom, just to account for all the possibilities that can happen there. Okay, so let's get a common denominator. We'll have to multiply this by x minus 1s, and over here we'll have to multiply by x squared plus 4. Alright, and then we will have to distribute all of this out, so ax times x is ax squared. Ax times 1 is negative ax, b times x is bx, and b times negative 1 is negative b. Over here, we'll distribute the c, so we'll have cx squared, we'll have 4c, and we're supposed to equal this whole mess up here. So 3x squared minus 4x plus 11. Okay, so and again we do the same thing, we're trying to group it by different types here. So sometimes when it's a little more complicated like this, like I have x squareds, I have x's, I have constants, I actually like to kind of color code it here. So for example, I'll put anything that has a squared on it in pink here, and then let's put something with x's, we'll put all those in red, so we'll have negative ax plus bx, that's the only things with x's in them. Let's go with light blue here for the constants, so we had negative b and plus 4c, and then I'll also color code the other side as I'm doing this. So my x squareds were in pink here, so I had 3x squared. My x's were in red, so I'll do that in red as well. And again, this just kind of helps you see it better with how you've organized it. If there's anything that kind of stands out, we can easily see it now because of that. So here's all the stuff that's supposed to add up to be x squareds. So I know that for my system here, a plus c will have to turn into 3. I know from the x values that these two combined are supposed to be negative 4. So negative a plus b is supposed to equal negative 4. And I know from my light blues here that this should add up to be 11. So negative b plus 4c is supposed to be 11. Okay, and now we just solve. It's got 3 equations, but the nice thing here is it just so happens if I add all 3 of these together, we're going to get a with negative a, that's gone, b with negative b, that's gone. It's actually going to eliminate 2 variables at once. So that's kind of a lucky break that we got there. It won't usually happen, but let's just add this whole stack together. A's are gone, b's are gone, and I have 5 c's. 3, negative 4, and 11 is equal to 10, so right away I get that c is 2. And then we go back, a plus 2 is 3, that means that a has to be a 1. And then if a is 1, negative 1 plus b was negative 4, that means b will equal negative 3. Okay, so and again, last step here, we're going to go ahead and take this and put it back into our original problem. So we had ax plus b over x squared plus 4, so 1x, or just x, minus 3 over x squared plus 4, and then our c value is over x minus 1, so finally 2 over x minus 1. And that'd be your final answer. Okay, so again, only twist there is because we had this square down here, we needed to account for, what actually turned out we needed the x there. Okay, the next one is kind of going to bring all of this together. So it's the same thing, we have a quadratic down here we can't factor, and it's also repeated. Okay, so think back to what we said before. If you have a repeated factor, you put it once, so x squared plus 3, and then the second time you put it, you have to put the squared on it to account for the fact that if you didn't have the square there, you could add them together right away, and you wouldn't need to do anything. Okay, now here's where it starts to get kind of silly, because we have 2 letters here and 2 letters there. So you can see if we had even more stuff down here, you get even more letters, and it kind of gets out of control pretty fast. But honestly, this problem is going to be very easy to solve once we get down to it, because there's not much to do for common denominators. So it's actually, even though it's got a lot of letters, it's actually one of the easiest problems there is. So let's continue from here. We're going to need to multiply this by another x squared plus 3. And the right side doesn't need to change at all. That's what's kind of nice about this. So we're just going to FOIL this out, and then we'll combine it with that. So ax times x squared is ax to the third. Ax times 3 is plus ax, or sorry, 3ax. B times x squared is bx squared, and b times 3 is 3b. Over here, these aren't going to change, so cx and d, and again, we know that's supposed to equal the numerator up here, so 2x squared, or sorry, to the third, plus x squared plus 6x plus 7. Alright, and here's what usually happens when you have so many letters. If you'll notice, I only have one thing with the x third on it, so I already know what a is right away. It's going to be the 2 here. I also only have one thing with the squared on it. Right here, bx squared, so b has to be this 1 here. So I immediately know 2 of my letters. I know from these that a equals 2, and then I know from these that b equals 1. So that's pretty handy. And then I can still set up my other equations, because I'm going to need to do that at some point. But having these 2 right away is going to help me do this pretty quickly here. So let's see what else we got. We have 3ax's and cx's. Those have to be a 6. So 3a plus c has to equal 6. I know a is 2, so let's go ahead and do that real quick. And so it turns out that c is actually 0. Okay, so this is actually what I talked about before. Sometimes when you're setting up these fractions, this x value isn't actually needed, but we do put it in there to account for the fact that there might have been a number here instead. Okay, so if c is 0, let's keep going here. We also had something with 3b and d, that's our constant value. So we'd have 3b plus d is supposed to equal 7. So b is 1, we already had that one. That means d is going to equal 4. Okay. So final answer, let's put it back into our original fractions again. We know from our setup that it was 2x plus 1 over x squared plus 3. And over on the side here, the c was 0, so 0 x's, and then 4 over x squared plus 3, all squared. And that would be where we'd stop. Okay, so just kind of recap here. We talked about all the different possibilities now. If you have linear factors on the bottom, you just put a single letter on top of those. If you have quadratic factors on the bottom, you put a linear factor on top. And then if you have repeats of any type, you build up to them until you get to the highest degree there.